Alright, today we're going to do a couple more things on our serializer. First thing I want to do is I do want to go ahead and switch over to using object arrays and type arrays for our parameter types and our arguments. And the reason for that is that looking ahead, most of the times that we're going to be using these methods and invoking them and relying on them, we're going to be presented certain things in the form of arrays of types or arrays of objects. I'm not necessarily certain about the performance characteristics of looping over two arrays as opposed to performing two enumerations on two enumerables. That performance difference, if even measurable, should be fairly small because we're looking at the added overhead of a method invocation as opposed to an IL instruction that would access an array directly, but then you have to count in the fact that, well, yeah, we're not invoking a method, but we are incrementing a local variable. And I know it just, I generally do spend, try not to spend a whole lot of time micro-optimizing things, but it's very hard not to when you're working with a system that's going to be this low level, and the fact that the binary serializers, just like the component map, are really the centerpieces of this entire framework. So using the enumerables, I figured in the last video I was writing it, I remember it was going through my head, enumerables should be fine, they'll work for everything, and technically you should always prefer using an enumerable of an object over a array of an object passing around for a variety of reasons. But then the more I think about it, the more I realize in this particular instance, shaving a couple nanoseconds off for a very little amount of work wouldn't be that big of a deal, and it'll just these methods did leave me with a bad taste in my mouth, with particularly over enumerating over two enumerables. And this is a completely valid use of enumerables, by the way. Just looping over them manually, accessing the enumerator directly is completely valid. You don't have to use a for each loop. But I figured the implementations themselves would actually benefit, and the clarity of the code would actually benefit if we switched to using arrays. So let's take a look at how to do that. The first thing we need to do is jump into our interface, our iSerializer. And then basically what I'm going to do is I'm going to jump into these two argument methods, and I'm going to change these enumerable of type to an array. If you guys are interested in a more in-depth discussion about the differences between these two, especially how it pertains to the design of your architecture between using an array of something and an enumerable of something, let me know. I'm more than willing to talk about why 99.9% of the time I would prefer accepting an enumerable of something as opposed to an array of something. But like I said before, I know all of the use cases of this particular serializer in advance, at least as far as the RPC framework goes, and we will be receiving data in the form of arrays that we will be able to dump straight into our serializer. That being said, if the things that we would be passing into our serializer down the road were things like lists, then using an enumerable would actually make more sense. And the reason for that is to shove a list into a parameter that requires an array would require a conversion, a very costly process. So again, it just boils down to what exactly we are doing. So now that I've done that, of course, to make it compile, I need to jump back over here and change the corresponding implementations. I will also, at this point, since this is a new installation of my of Windows on my machine, and ReSharper quite hasn't picked up on all of my preferences yet, I will go ahead and turn solution-wide analysis on, because I do really rely on that little errors number on the lower right-hand side of the screen when we have solution analysis on. I really do like that. So anyway, now that we've done that, let's go ahead and change our signatures. I'm going to switch over from enumerable blah to array of blah. Enumerable blah to array of blah. Blah, blah, blah. Okay, so basically we're just going to have to rewrite both of these methods, and it's really not that difficult to do. So for our write arguments method, I'm simply just going to remove it, the entire implementation. I'm not going to perform, just like I did before, I'm not going to perform bounds checking. So I will go ahead and assume that the types and the arguments are both the same length. So I'm going to say for var I equals 0, I smaller than types length I++, and then I'll say write object passing in our binary writer, our types at I, and our arguments at I. So you might be wondering why I'm just assuming that these two arrays are going to be the same. Why am I not doing a precondition check at this point? And the answer to that question is that bounds checking for arrays is actually already provided for us by the CLR. If this were a different kind of method, like let's say something that you would find deep in the bowels of some business, oriented domain layer somewhere, I would certainly write a if check at the top of this method, ensuring that the types and arguments arrays are both the same length. But in this particular case, it won't actually do me necessarily any good because I'll still get an exception if I try to access things out of bounds, which is nice. So I'm not going to corrupt memory or anything, which is good. But the added if statement I just don't feel is appropriate for the kind of code that we are writing in this method. Anyway, you'll immediately see that the method's implementation cleared up quite a bit. So now that we've done that, I'm going to go here. For the sake of just clarity, I'm just going to delete everything in this method and just rewrite it from scratch. So the read arguments is going to have to first instantiate an array, so a new object array, and then I'm going to pass in types.length. Remember, we're wanting to return all of the arguments that correspond to the types that were passed in that array. Then what I want to do is do something like for var I equals 0, I smaller than types length, I plus plus, arguments at I equals read object, not onject, I don't know where the n came from, passing in reader and passing at types at I. And then we simply return arguments. So again, the method cleared up quite a bit. And now we are accepting type arrays as opposed to IEnumerable of types. So now that we've done that, let's go ahead and test our write arguments and read arguments methods. I'm not expecting anything really crazy to happen with these. They should work just fine. So I'm going to jump into our simple serializer tests fixture over in my tests project. And I'm going to scroll down to the bottom. And I'm just going to write one test for this. I'm going to say public void can read and write arguments. Now again, some people will be like, well, you're testing two things in this test method. And I am, but I'm doing that in the interest of time. Because the only way to write a proper unit test that only tests either the write object method or the read object method, or in this case, the write and read argument methods, is if I were to manually construct a byte array that I could compare the values against, and that would just be a pain. So I am rolling both of these units into one test, which is against what most people would consider to be appropriate, but in this case, I think will work just fine. So anyway, so I'm going to say var types equals, let's do a new array. We're going to do type of bool, type of, let's do a GUID, type of date time, because those are more, well, actually, yeah, sure. And then type of ulong. That's a type you don't see very often. Anyway, so now that we have our types, let's fill in our arguments array that'll correspond to these types. So I'm going to say arguments. I'm going to actually not use, because I don't believe in implicit typing might get mad at me in this case. So I am going to explicitly declare the type of the array as object. And then what I'm going to do is pass in a bool. So let's do false. Let's do true. Pass in a GUID. I'm going to pass in a new GUID of something. And that something I'm going to generate by going up to the Tools menu, jumping down to Create GUID, just like what I did before, hitting New GUID a couple of times because why not? And then I'm going to pass that into the constructor. Next up, I am going to pass in a date time. So new date time, sure, why not? 121. And then finally, I'll pass in a ulong, which will be a really, really big number. I'm actually not sure what the suffix is for ulongs, for number literals in C#. So instead, I'll just do a cast to ulong. Hopefully, the compiler will pick up on that. I'm not entirely sure if it will, though, because again, very uncommon type to use. Okay, so then we're going to say test serializer, and I'm going to say BW goes into serializer, which we forgot to instantiate the serializer. It's kind of hard to test the serializer if we don't instantiate it first. So immediately after our arguments right there, I'm going to say var ser equals new simple serializer. And then I'm going to do BW goes into ser.write arguments. I'm pass in our binary writer, pass in our argument types, and pass in our arguments themselves. Then I'm going to do BR goes into, now this is where things get fun. So I'm actually going to split it here into a multi-line lambda here. I guess you could call this a closure since we'll be hoisting up a couple arrays. But this will have to be multi-line. So I'm going to say var read arguments equals serializer dot read arguments, passing in our binary reader and the types of those arguments. So now I'm simply going to say read arguments at 0 should be arguments at 0. Should work just fine in this case. So read arguments dot 1. I can just write a loop, can't I? This is getting annoying. For each var I equals 0, I smaller than arguments dot length I plus plus, and then I'm going to say read arguments at I should be arguments at I. So just to clarify, what we're doing is we're ensuring that these arguments that were returned by the serializer have the exact same equality as the arguments that we provided to the right portion of that. So let's go ahead and run our test and see what we get. And we get success. And just to make sure that that success is a valid success, I'll just quickly, well, no, I mean, I'm fairly certain. We can, if we're really super paranoid, we can do a breakpoint here and inspect the, get out of the way. Go. There we go. Our arguments, and we can see all these values are exactly what we passed into the right arguments portion of the method. Okay, so that's the basic use case for all of our basic types. Now we will be adding to the basic types. Basically, any types that we know how, any like sort of the atomic types, the non-complex types, the simple types that we need to write to something, we'll just add another clause in here. Again, it's not, it's fairly efficient. As long as if we could do some testing to ensure that the most likely types are at the top of the if chain. We could even do a dictionary, all that fun stuff, but we're not going to worry about that. And the idea here is that things like IDs, like actor IDs and player IDs, will go here. But there's actually quite a few other things that we need to be able to read and write. In particular, one of those is an array. Well, we will need to be able to serialize an array of some value. And that value could be anything. It could be a byte, a string, an enum, an array of GUIDs, and so on and so on. So we need to make sure we're capable of doing that and having our serializer just figure that out for us transparently. So what I'm going to do first is I will start with writing a test. I'll start with writing a test since all of the public interface of our binary serializer is already in place, so I can write a test before diving in and fixing up the code. So say test public void can read and write. Let's do an array of I don't know, int 30 array of strings. Array of strings. So what I'm going to do here is I'm going to say var array equals new hello world stuff. Hey. Now you might be wondering how we might be able to handle null types. We're actually going to be dealing with nullable things later. For now, I'm probably going to assume that integers are going to not be null, and if they are null, I would want to actually add in, or maybe change them into an empty string or something like that. That gets a little tricky without introducing some sort of flag to indicate whether or not the value is null. It might just be easier just to say that string arrays cannot be null, or strings in general cannot be null, which I think is a fairly decent enough way to go about these the serializer, considering how it's going to be used. Because stuff and things. So that's an array of stuff that we want to serialize. I don't know if anything that I just said was articulated well enough, and I apologize. We'll instantiate our serializer. we'll then just say test serializer. We'll pass in BW, ser write object, BW type of string array, and then pass an array. And then BR, I will go ahead and make this multi-line as well. I'll say read array equals ser read object, BR, type of string array. Now remember, the type of string array is incredibly important. It's not type of string because we're not serializing a string. We're serializing a string array. So then what I have to do is say for var I equals 0, I smaller than array length I plus plus, and then array at I should be read array at I. Now some people who are, what are you yelling at? Oh, because I'm going to have to cast it right here into a string array. That's why. Okay, people more familiar with the Fluent Assertion library might be asking why I'm not using one of their more specialized array comparison or enumerable comparison methods. The reason for that is I just haven't gotten that comfortable with them. When doing things over collections like this, I find this to be better. Or not better, clearer, I guess, especially to people who aren't familiar with it. I am also going to assert before this that readArray.length should be array.length to ensure that the arrays are the same length. Alrighty, so how do we read and write an array? Well, first we can ensure that that this breaks by doing that, and we say cannot write system string array parameter name value. Okay, so how do we do that? Well, if we jump into our simple serializer and we come up to the read and the write object are really where we're going to put a lot of the brains of the serializer. And the reason for that is the write arguments and the read arguments both depend on the capabilities of read and write object. In addition, as well, as you'll see, read and write object are actually going to be or could be recursive. So I want to also see about the possibility of storing an array of arrays as well as just a single dimensional array. So the write object, before we go ahead and just give up and just say write simple, because write simple is kind of a catch-all. We're going to be checking for a variety of things. And in this particular case, what we want to check for is whether or not the thing passed in is an array or not. So what I can do here is I can say if type dot is array. Well, that was pretty convenient. The is array property is a boolean on the type, and it determines or tells us if the type is an array or not. So now what I can do is I can say var array equals cast to array value var element type equals type dot get element type. So there's two interesting things to note about these two lines of code. The first one is we are casting the value into the array class. The array class is actually the base class for all other array types. In fact, it says that right there in the documentation. Then we have the get element type. And the get element type is going to return us the element type of the array. For example, if we have a string array, it'll return a system type of string. So now that we have the array, we can access certain values out of it, and that we have the value type so we know how to serialize those certain values. We can simply loop over all the items in the array and write them out using our write object method, in fact making it recursive. However, we also need to indicate the length of the array. Now, we don't have to indicate the type of the array. That's important to remember throughout this entire serializer. And that's because the way that I intend the serializer to be used is it to both sides, both the side that's reading the data and both the sides writing the data, so both the client and the server, know what types it should be reading and writing without those types being annotated in the data stream itself. So again, we don't have to tell it what type of array, because when the RPC framework will turn around and deserialize a message, it knows what type of array because it knows what the parameter type of that method it's trying to call is. So all we need to pass in is the length of the array. So I can say writer.write, that's not even close to how you spell write, writer.write, and I'll pass in array.length. Then I'm going to say for var I equals 0, I smaller than array.length I plus plus, and then I can say write object, passing in my writer, passing in my element type, and passing in my array at value. Which I can't remember if this is actually supported or not. Seriously? Okay, so we will have to go ahead and turn this into a for each loop. So I'm going to say for each var item in array, which does work for whatever reason, pass in item. Okay, so it's a very simple writing of array. You see that write object is now recursive, so in theory, it should allow us to have or serialize an array of arrays. The final thing I want to stress this is incredibly important. Be sure that you add an else here. Because remember, if the type is of an array, we call back into write object and do this whole process over again. We don't want to write simple after finishing the write object, after finishing serializing the array. Anyway, pretty straightforward implementation of serializing arrays. So as far as reading it in, that's going to be pretty straightforward as well. I'm going to jump down into read object, and I'm going to say if type is array. Then I'm going to say var element type equals type get element type, because I need to extract the type of array that it is. Then I'm going to say var length equals reader.readInt32. The reason I know that we are reading in an int32 is because array.length, which we write here, is of type int32. So now that we have the element type and the array, we can actually create an array. I can say var array equals array.create instance, passing in, not surprisingly, the element type and the length. Then we simply have to say for each var I equals 0, I smaller than length, I plus plus, and then we can say array.setValue, passing in read object of reader and element type and I. Then we return array. Note that no else statement is required here because this will abort the method right there. Okay, so we're using the set value method on the array, and that's a method that allows me to set the value of a array without having a typed array. Remember how this array.create instance, if you look at its return type, it returns the base type array. Well, unfortunately, we can't use the normal means of indexing to set a value on an array that is of the base type. So we're going to have to use something else. But fortunately, the array base type gives us this handy little set value method that'll allow us to do just that. All right, so let's go ahead and run all of our tests and see what happens. It seems that we get a... Oh, there we go. Let's run that again to make sure it wasn't the test causing VS to hang. No, it wasn't. Okay, so we can read and write an array of strings. So that's really cool. Let's jump back into our... Actually, I wonder. Nah, let's not worry about that just yet. Let's jump back into our test and try to do an array of arrays. Just to see if that works. Well, yeah, let's just... I don't know. A fun little test. I don't know if we'll ever be using an array of arrays. No, I will not be supporting multi-dimensional arrays. Okay, so now we have an array of arrays. So you see that, oh, we're getting an error, blah, 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 blah. What isn't it liking? Oh, derp to derp. There we go. Ignore me. Well, I guess You can't because Visual Studio decided to hang again. There we go. Okay, so we have an array, and then we have 3 arrays inside of this one array. So then I'm going to say var ser equals new simple serializer, desc serializer, bw ser write object, passing in our bw and our type of string array, and passing in array. Then I'm going to say var red array equals string array. See, what I'm testing right now is basically the ability to nest multiple complex things in each other. Basically, how this recursion is going to work. Because notice how we're invoking itself. So I want to be able to support multiple levels of complexity. And what I mean by that is we see here that our write simple method just deals with primitives, but what about, like, for example, an array that has items of type enum? Because enums are going to require a different set of complex behavior that will be present in the write object method, but not in the write simple method. So I'm just trying to see if we can get away with kind of stacking our relatively complex serialization schemes. So I'm going to say for so red array dot length should, that's not how you spell should be array length for var I equals 0, I smaller than red array length I plus plus, var inner array equals red array at I. Then I'm going to say inner array dot length. That's again not how you spell should. I don't know why I'm not hitting the H there. Should be, what should it be? It should be array at I dot length. Then I should say for var j equals 0, j smaller than inner array length j plus plus. And then I should say inner array at j. Is the H key just not working on my computer? Should be array at I at j. All right, let's go ahead and run that. And we get success. Okay, so the next thing, or I guess the last thing I kind of want to do in this video is dealing with enums, just to get another really, really basic one out of the way. Enums actually won't be able to be read or written from as as this currently stands. And actually, I can go ahead and show you guys. I can go ahead and write 2 tests to show you guys that. So what I'm going to do is up here at the top of this test fixture, I'm going to say enum test enum, and then I'm going to say 1, 2, 3, 4. And then let's set 2 to 6, 3 to 10, and 4 to 25. And then to make things even more interesting, I'm going to specify that the backing type of this enumeration is a byte. So not only do we have a non-standard ordering of our members, but we also are indicating to the CLR that we want the backing type of this enumeration to be a byte, as opposed to an int32, which I believe is the default. So scrolling down at the bottom, I'm going to write 2 tests. I'm going to say public void can read and write enum value. And I guess I can go ahead and make this a parameterized test, and I don't even think that was proper pronunciation. But I'll say test enum value. This is going to fail, actually. This won't let me compile because the test enum is a private type, whereas this is a public method. So I'm actually going to jump all the way back up to the top of my file and change my enum from private to public by adding the public accessibility modifier to it. So now that I've done that, let's scroll back down to the bottom, finally again. And I'm going to write a couple test cases. So test case test enum.1, and then I'm just going to copy and paste 2, 3, 4. All right, and then I'm going to say var ser equals new simple serializer, test serializer, passing in BW, ser write object, BW, type of test enum, enum value, and then BR, ser read object, BR, type of test enum, dot should, and I missed the H, I keep on missing that H, should be enum value. And then also, just for added bonus, I'm going to say public void can read and write enum values to array. And this is just going to be normal test. Then I'm going to say var array equals new test enum 1, test enum 2, 3, 4. I'm going to say var ser equals new simple serializer, test serializer, BW goes into ser write object, passing in BW, type of test enum, then the value, which is in this case is right. I already messed up the test. It's type of test enum array that we're passing in. I'm going to say BR, I'm going to break this out into multiple lines. I'm going to say var read array equals BR read object, whoops, ser read object. Oh, come on. Read object BR passing in type of test enum array. Then I'm going to say read array length. I have to cast it first, don't I? Test enum array. Read array length. That H key should be array length. For var I equals 0, I smaller than array length, I plus plus, read array at I should be array at I. I don't know, this just isn't a good day for my typing, apparently. That took way too long to write those two methods. Now let's run our test. Both of these should fail, and they do. So now let's go ahead and fix it. And this is actually going to be pretty straightforward. I'm going to jump into, basically what we're going to be doing here is we're going to be serializing the enumeration by its backing type. And then we're going to be using the serialize symbol for that, or the write symbol for that. And remember, the backing type is what I specified right here, in this case a byte. And then we're simply going to be casting it back into that enum when we read it in. So very straightforward. So on read object, let's start with the write object. So with write object, I first need to determine if it's an enum, which fortunately I can simply say else if type.isEnum. Then, after I do that, I just have to say write simple, passing in our writer, passing in our type passing in enum.get underlying type of type, and then passing in value. So a couple things of importance here. We're just adding another else if block right here, using the isEnum flag to determine if the type is an enumeration. Then we're bypassing write object and going straight into write simple. The reason for that is that the C# or the .NET specification actually tells us that enums can only have a certain range of different backing types. You know, it can only be a byte or an int. I think you can use long, if I'm not mistaken. There's a set of types that you can use as a backing type for an enum, and they're all covered by the write simple method. So it's impossible, for example, for an enum to have a backing type of an array. That just wouldn't make any sense. So because of that, I'm just going to write simple instead of write object, because I know write simple will be able to handle it. And we don't actually have to add anything to write simple in this case, and the reason for that is we already have all of those types specified in the massive if block. In fact, I can go ahead and get rid of these curlies because they're kind of ugly. Okay, so that's our write object. Now our read object is going to be just as simple, really. Coming back here, I'm going to say if type.isEnum, then I'm going to say return read simple, passing in reader, and then enum.get underlying type type. So remember, enum.get underlying type just, well, it returns the underlying type. So if you have a backing type of byte, it'll return system.byte. If you have a backing type of int, it'll return system.int32, and so on and so on. All right, let's go ahead and run our tests again. So adding 4 lines of code, and it still fails. Invalid cast, object cannot be stored in an array of this type. Well, that's interesting. So it doesn't mind writing the array, but it really doesn't like reading the array. So let's go ahead and make sure that I'm not doing something stupid. And then I'm going to hit, looks like these failed too. Ah, yeah, these failed because I didn't cast. I needed to actually perform a cast right here for test enum. So I need to say test enum cast and then there. So by adding that cast, these methods should now be successful, and they are. Because remember, the read object isn't returning an instance of the enum type, it's actually returning a one of the backing types. In fact, that actually could be one of the issues with this. I'm wondering, I'm going to go ahead and undo that change right there, because that might be exactly what's causing the array bit to fail. So what I want to do is I want to jump back into the serializer and have the read object actually return a type that's appropriate for this enum. I'm wondering if there's a built-in way to do that in .NET. So if I do enum dot, what is toObject? Returns an instance to the specified value. Huh, that might work. So let's say enum.toObject, passing in the enum type, which is type, and then passing in the value of the, which is the result of read simple. There we go, and it works. So for those of you guys who might be confused about why this fixes the problem, and it's because, again, the read object was originally just returning read simple, which is only going to return a value of the type. It's going to return a boxed value of the type it was asked to return, the underlying type. So, for example, if the enum had a backing type of byte, it would return a byte, a boxed byte. If it had a type of int, it would return a boxed int, and so on. It wasn't actually returning objects of the type of enum. So we needed to actually, well, convert those types. And we used the enum.toObject method to do that. So the enum.toObject method took in the type of our enum, the value of our enum in the form of its particular backing type, and it returned an actually valid enum object for that. That was interesting. I'm wondering why I didn't run into that problem before, but then again, this is why testing is such a good thing to do. But anyway, yeah, so we have arrays working and we have enums working. So those are two big things definitely with what we want to do with this framework. So I guess we'll see you guys next video.